Okay, so Alan, welcome back, and also welcome to another course in our calculus course series. Now, in the previous course, what we did essentially was that we covered essentially everything there was in mathematics class 1 to 5, and of course, you know that essentially all of those chapters were taken from the NCERT textbook. And we covered essentially class 1 to 5. I mean, I picked essentially the important things in those chapters, essentially put them together, and essentially we covered that in about 7.5 hours, not more than that. Okay. Now the rest of these courses, I suppose, are going to take a little bit more time, meaning that, for example, this chapter over here that we are going to do right now is chapter 1 of class 6, and I think this chapter alone is going to take up one complete course, maybe 10, 15, 20 hours. We'll see essentially how that goes. Now this chapter is about numbers, knowing your numbers, and essentially about the operation that you do on those numbers, and so on and so forth. So I hope that you're going to like this course. And so let's get started. Now what we have here is essentially a text. So I will try to go through this text. Essentially, you already know that essentially that you use numbers essentially in order to essentially to count objects. Meaning that, for example, you have a number of I don't know, any sort of object. So you count those objects, and then you come up with a number, and then that number essentially, well, is, I mean, the count that you have on that on the number of objects essentially is then expressed through a number, right? For example, you can say the number of students in the school, or basically we can also, of course, communicate larger numbers. Now it seems that many thousands of years ago, of course, people, because they didn't have much use for essentially for larger numbers, or essentially for very small numbers, we didn't have essentially those numbers yet. We might have had essentially only the numbers that you can count on your fingers, or a little bit past that, but not more than that. But then over time, because essentially people and the society have gotten a little bit more sophisticated, and we needed essentially to do more things. Of course, the more that you want to do, the more mathematics you always need to have, because anything that you want to do with your mind, you will always have to essentially use mathematics, and then essentially use mathematics in one of the branches of science. For example, you use it in physics, then you're using your mathematics essentially in the physical world. You use it essentially in chemistry, you're using your mathematics essentially in the chemical world, and so on and so forth, right? Today, for example, we use our mathematics, for example, in computer science, in order to write programs, make computers, and so on and so forth. So the more sophisticated that we get, of course, the more sophisticated our mathematics has to get. Now, basically, of course, we can use numbers for many different types of purposes, which we will see as we go along essentially in our courses. And then basically we will learn essentially the basic operations on those numbers, and other more advanced operations on those numbers. And so that's basically that. So I will end this video here, and in the next video we will talk about basically comparing numbers. Thank you. Okay, so now before we get to essentially to comparing numbers, we need to have a little bit of we need to review, or essentially expand a little bit of our basics of numbers, basically. and then we can get into comparing numbers. Now, I didn't discuss these things on purpose in the previous course because it was not the right place to discuss it. Now we can actually discuss these things and actually use it for some real practical purpose. Okay, so now then the numbers that we have, as we mentioned basically in the previous course, are numbers essentially that we use in mathematics, is essentially in a system called the decimal number system, right? So we have essentially the decimal number system. And the system is called basically decimal for a reason, of course, for a good reason, because it is actually decimal. Decimal, the word itself means, it essentially means, according to dictionary.com, it means pertaining to 10th or to the number 10, meaning that essentially it's a base 10 number system. It's essentially a base 10 number system. And what that means is that essentially a base 10 number system, that means that essentially the digits that we have in this number system are essentially, we have 10 of those digits, meaning that we have essentially the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if you count these digits, you will see that it is, of course, 10 digits, right? 0 to 9 would be 1 to 9 would be 9 digits, plus 0 would be 10 digits. There are, of course, we have other number systems that we use, for example, in computers. One of those essentially, for example, would be the binary number system, and the binary number system would be a base 2 number system, which means that essentially then the number of the digits that we have in this system would be just 2 digits, a 0 and a 1. And of course, this system is supposed to be used essentially in computers. In computers, essentially we have of course digital electronics, and digital electronics essentially works in the way, essentially in such a way that you all essentially either at any point in time, and essentially at some point in some circuit, you either have no voltage, meaning 0 voltage, or you have essentially, for example, 5 volts, right? So when you have essentially the 5 volts on that point in the circuit, that is represented by a 1. That means essentially a yes, for example. And then when you have no voltage over there, that's represented by a 0, and then these are essentially the only 2 digits that this system has, meaning that essentially then a number in this system would be 0, for example, 10110, for example. That's a number in binary. Now, of course, you can convert it to, for example, to decimal as well, but that's not the subject of our discussion right now. Coming back basically to the decimal number system, we have these essentially these 10 digits, and that's a base 10. And the decimal number system is also basically a place value number system. I have discussed these in the previous course, but now I want to make it essentially final and formal so that we can do what we need to do with them. A place value number system, of course, the decimal number system is a place value number system. But then again, we have some other number systems that, well, they are not essentially place value number systems. Meaning that, for example, the Roman number system. In the Roman number system, you have all of these different characters that you use in the number system. So let me show you. So these characters that we have in the Roman number system are basically IVXL, and CD, for example. These are I suppose all the can. There is also an M. There is also an M there. Actually, we are going to do a little bit of work on these Roman number system in this chapter itself. And then these are essentially the value of these characters would be 1, 5, 10, 50. Would be 1, 5, 10, 50. And then we have essentially 100, 500, and 1000. Then we have a 100, a 500, and 1000. Right? Now, what this means, essentially, this is the value for this character. This is the value for this character, and so on and so forth. And then when you want to essentially, when you want to write down a number, it gets a little bit, I mean, it's a little bit confusing, and you can come up with essentially with very long numbers, basically, if your number gets a little bit large. Meaning that, for example, for 1, in decimal we write a 1. In Roman you would write just one of these i's. That's a 1. If you want to write a 2, you have to put 2 of these together. If you want to write a 3, you have to put 3 of these together. Meaning that essentially the value of this character, essentially the value of, now we have essentially these two characters put together one after the other, and their values are supposed to be added together, meaning 1 plus a 1 is a 2. And now essentially I have 3 of these characters. The values have to be added together, right? So you have essentially a 1 plus a 1 plus a 1 is equal to 3, right? And then if you want to write a 4, you might expect that you have to write essentially 4 of these together, which doesn't, I mean, it's not like that, doesn't work like that. You would put you have to use a 5. You have to use a 5, and this is the 5 essentially that I have used. And then you have to subtract 1 from a 5. When you want to subtract, you put it on the left hand side of the character. So this is a 5 minus a 1, that's a 4. Now if you want to write a 5, then you would write essentially the 5 that we have here. If you want to write a 6, you cannot use essentially 6 of these ones put together. You have to use a 5 again, but then add 1 to it. And adding 1 to it, you use the 1, you put the 1 on the right hand side of the character. That means you're adding to it, right? Now if you want to essentially to write, for example, 1500, you have to start with the largest value character, which means that essentially 1500 is essentially nothing but the 1000 plus a 500, right? 1000 would be essentially this character over here. A 500 would be this character over here. Putting them together, you would get an MD. MD means essentially 1500. Or essentially, for example, 600 would most probably be, I might be wrong here because I'm not really very much familiar with the system, but most probably it's going to be essentially MDC. That would be essentially 1600, because that's essentially that's 1000, that's a 500, that's a 100. 500 plus 100 is equal to 600, so that's 1600. Now I'm not trying to teach you how to write down these numbers right now. What I'm trying to say is that this system essentially, well, we get a couple of characters like this, and we get essentially a couple of characters over here in the decimal number system. There is not much difference there, but the problem here is that when you essentially when you put essentially this when you write down your number, this character comes to the right hand side of the number only because it has the least value among essentially all of these characters here. And then you write your D over here only because it has a little bit more value than C. And then you write your M to the left of all of these two only because it has more value than these two. Otherwise it doesn't matter essentially where you put these. Whether you put your M over here or over here or over here, the value of the M is going to be 1000. Whether you put, of course you're not supposed to do that, but of course it doesn't matter where you put it. The value is going to remain the same. Whether you put your D over here in the middle or on the right or on the left, your D is always going to have a value of 500. And of course your C, the value is always remains 100. And then if you want, you can imagine that if you want to write a large number like, for example, 5,252,000, for example, 3,365, something like this, I wouldn't even know how to write that number. I mean, it would probably take a whole line to write it down, and then who would even be able to read that number, you know? So it's just, there is no place value here, okay? And because of the fact that there is no place value, then there is no zero, and so because of that, then essentially the number gets too cumbersome and large and long and so on and so forth. Right? Now basically the art of the decimal number system is the fact that essentially the power of the decimal number system is because of the fact that there is zero in the decimal number system, which is something that Indians invented thousands of years ago. And I suppose the rest of these characters, of course, these are called the Arabic numerals, but I think they primarily come from India somehow. Of course, you have to do your research over there. And also essentially the system itself, the decimal number system, I suppose that also comes from India. So the whole thing, the whole package essentially seems to essentially have come from India. Okay. And again, the power of the system is that first of all you have the place value, and so because of the fact that you want to have the place value, then of course you need to have the zero, because otherwise you wouldn't be able to move your numbers around, right? I'll show you essentially what I mean. So what I mean by the place value in this system is that if I write a 526 right like this, as we mentioned before, basically in this number system, here we have the ones place value. Here we have essentially the tens place value, and here we have the hundreds place value, right? And of course you're familiar with the models that we used for numbers. We use essentially the pebble model, for example, and essentially you have, for example, if you want to write an 8 in using the model, you would essentially have basically 8 pebbles. 8 pebbles means essentially an 8. So you can just simply count them, and that would be essentially your number. That's the model that you can use. Now once essentially the number of pebbles gets way too large, as we saw in the previous course, we have to group things together so that we don't have to keep counting things over and over again. Meaning that, for example, for a number like 526, you would have exactly 526 of these small pebbles. And of course, it wouldn't be easy to count them every time you want to do something with them. So then what you can do is that you will put them together in groups of 10. So I get basically, let's say that this is one group of 10, this is another group of 10, and let's say that I put essentially 10 of these in a group, and I call it the group of 100. So I'm going to draw it like this. I'm going to call this a group of 100, another group of 100, another group of 100. This is a group of 10, this is a group of 10, right? So you can imagine that essentially this is 10 of 10, this one group, for example, is 10 of these groups put together. Put 10 of these, essentially put 10 of these 10 groups together, you'll get the group of 100. And so I need essentially another 2 of these, so that's 100, and that's another 100. And that's a 5, 1, 2, 3, 4, 5, so that's a 520, essentially two groups of 10, and 6 loose ones, right? Now, because of the fact that essentially the decimal number system is a place value number system, since once we have essentially grouped these together, then basically what we will do is that I will put essentially all of these in the ones place value. I have 6 of these over here, so I put a 6 over here in the ones place value to mean that I have essentially the 6 groups of 1, right? Then I pick essentially all of these together. I have 2 of these. I put a 2 over here in the tens place value, and of course these are groups of 10. And when I put this 2 over here, that means essentially I have essentially 2 groups of 10, which means a 20, right? So I don't, when I write the 2 over here, the 2 means a 20. But then when I write the 6 over here, that means just a 6. So that's the meaning of the place value, right? And then also, basically I have all of these groups over here. I've put them together and I have 5 of them. So I put the 5 over here in the hundreds place value to mean that essentially I have 5 groups of 100, which automatically means essentially 500, right? And so essentially then what that means is that when I put the 5 over here, that means a 500. When I write a 5 over here in the hundreds place value, it becomes a 500. When I write essentially a 5 in the tens place value, that becomes just a 50. And if I write basically a 5 over here, that becomes just essentially a 5, meaning essentially 5 of these pebbles basically, right? So that's the meaning of the place value, right? And of course, when you write a 0 at any place value, that means there is 0 of those. For example, this 0 over here, that means there is 0 ones in this number. There is 5 10 in this number and 6 hundreds in this number, right? So this you need to, I mean, this model, you need to understand it so that we can actually work. We are going to work a lot with this, with essentially with these numbers, especially in this chapter, and then as we go along in all of the books that we have, essentially class numbers 6, 7, 8, 9, 10, 11, and 12. We are going to be doing all kinds of things on these numbers, and it's of course it's going to be a very exciting journey. Really exciting things there are in these books. You could have a lifetime of fun and learning with these books. Okay, so now we have essentially, now we understand essentially that essentially we work with the decimal number system. We work with the decimal number system, which is a base 10 number system. We have essentially 10 digits over here that you can put essentially in any of these place values, meaning that in the ones place value you can use any of these digits, or in the tens place value you can use, and so on and so forth. And you understand essentially what it means what the number actually means. meaning that essentially when you write a 526, that's a 526. So a 500, that means essentially 5 groups of 100. A 20, that means 2 groups of 10. And a 6 means 6 groups of 1. Now, if you have understood this, now we can essentially do all kinds of things on these numbers, meaning that, for example, we can compare them together. So that's which is what we will do in the next video. Thank you. Okay, so now let's get to essentially comparing numbers. Now so how do you compare numbers? So in order to answer this question, you need to know essentially how you want to know how to compare numbers, right? And of course a number would be, so essentially comparing numbers would be like, for example, 481. It's not very great. 481 and, for example, 522, for example. Which one is greater, right? And you can use essentially two symbols here, less than. You can use the symbol less than over here. And you see from the left hand side, when you see essentially this, there is essentially these two, this symbol, there is essentially two variations of this symbol in mathematics. So there is this one and this one, right? And of course you know that in mathematics essentially you have to come from the left to the right, right? So when you come to the when you come from the left, you get to this side of the symbol, and of course whatever goes into the mouth of the symbol is greater. Whatever goes into this other end of the symbol is smaller, right? So this is the mouth, this is the tail, I would say, for example. So whatever goes into the mouth is greater, and whatever goes into the tail is always smaller, right? Now, when you have this symbol over here, you can have it this way or this way, and you're coming from the left, of course. So when you get to the tail of the symbol, so then that means that the symbol is essentially the smaller symbol. And then again, when you come from the left, when you get to the mouth of the symbol, then that symbol is essentially greater, right? So that's one thing. Now there is another variation of this symbol, and that is we have essentially smaller than or equal to, or we have also essentially greater than or equal to. So the equal sign can also be combined with this symbol. The same equal sign that we have in mathematics, for example, 2 plus 3 is equal to 5. The same equal sign, you can either put it over here or you can put it over here. Now if you put these, essentially the equal sign, if you put it over here, this then becomes basically smaller than or equal to. And you have to pay attention to the or, essentially, to the word or over here. It's not an and, it's an or. Okay, we will get to essentially the difference between and or later on, but it's smaller than or equal to, right? So because there is the equal sign over here, when there is the equal sign over here, we have essentially the symbol essentially becomes greater than or equal to, right? So for example, I could say that, for example, 2 is less than or equal to 2, for example, which is a true statement, right? I could say essentially 2 is less than or equal to 5, for example, which is a true statement. This is a true statement because 2 is equal to 2. This is a true statement because 2 is less than 5, right? And in the exact same way, you can essentially use the symbol to do different types of things in mathematics. Really handy symbols. You can use them everywhere to do all kinds of things. Now, you want to essentially we want to compare numbers, and so essentially, and one thing that I need to let you know from the beginning. Well, I'm not against memorization, right? Memorization is sometimes a good thing. Meaning that, for example, there is a whole bunch of calculation that we are going to need to do, and of course we need to memorize a whole bunch of things. Meaning that we need to memorize essentially, for example, what is 14 times 15, for example, or 14 times 16, or 17 times 18. All of these you need to know by heart. Okay, otherwise our work becomes a little bit it gets a little bit we will have essentially some problems along the way. So when we get to essentially to the right place, I will ask you to memorize a couple of things so that we can use them in calculation. But then essentially memorizing a bunch of numbers, for example 14 times 15, is not a problem because you understand essentially what is the concept of multiplication. You know what numbers are. So then 14 times 15, you already know them, you already understand the meaning of it. And so then if you were to essentially every time you calculate essentially 14 times 15, you would have a lot more time, you would have to spend a lot more time on mathematics than you would have to if you knew essentially a couple more essentially multiplication tables. Okay, so memorization over here is absolutely okay, no problem, and we will actually do it in order to make things simpler for us, right? But memorization in mathematics, essentially when you don't understand something, is just simply stupid. It's absolutely stupid to memorize something in mathematics when you don't understand it, because of the fact that essentially then, well, you might get to some places with this method, but you will not get essentially to calculus with this method, right? You are most probably here because of the fact that you had problems with basic mathematics or with calculus, and you've come to these courses in order to solve these problems. And to solve these problems, you need to understand everything that you don't understand. Okay, meaning that essentially calculus is not something that you can just memorize, or even the basics of calculus, which is essentially the basic mathematics. When you want to use your basic mathematics essentially for calculus, it's absolutely impossible to memorize anything. You have to understand everything and move forward, which is essentially very easy, because everything that we need for calculus, we will explain them, and of course we will explain them in such a way that all the basics for that topic essentially have been explained already before, so then you will understand everything, right? And that's the only way to understand calculus. Okay, now now when it comes to, for example, to comparing numbers, there are I wouldn't say most people, but there are some people that would follow essentially steps, and they will memorize those steps, and then they will follow them. Of course you will get the right answer, but then the problem is that when you do that, you're just wasting your own time, because you didn't actually understand what you did, because it was based on something that you read from somewhere and you didn't understand it. So it's just not the right thing to do, and more importantly, this whole thing, even if you get it up to before somewhere anywhere before calculus, when you get to calculus, the whole thing is going to break down. Okay, so there is no need to do that. Now when you want to compare numbers, so essentially there is the word compare over here and the word numbers over here. So then you need to, if you don't know how to do that, then you need to break the question. Then the question, you need to break it down for yourself. How do I compare numbers? So essentially, what is numbers that I want to compare them? And in the previous video, we saw essentially what numbers are. For example, an 8. For example, we saw that essentially we have 8 pebbles over there, and 527, for example, is essentially this blocks of 100, and then blocks of 10, and then blocks of 1, and so on and so forth. So you understand essentially what a number is. And to compare essentially what and so since we want to compare numbers, that simply means essentially I have two numbers over here, one over here and one over here. I want to compare them, meaning that I want to know which one is larger, right? So which number is going to be larger? The number with the more, essentially with more number of pebbles, is going to be the larger number. It's a very simple thing, right? So now we can essentially we can start, and hopefully you will generalize what I said over here about understanding everything, and of course memorization. Memorization is useful in many situations in mathematics. It makes your life sometimes very easy, in case you, provided that you understand essentially whatever it is that you have memorized. If you understand it, it's okay, you can do it, and it makes your life very easy. Okay, so there is the memorization and there is understanding. When you don't understand something, you have to understand it and move to the next things, basically. So hopefully you will generalize this concept to everything that we are going to do for essentially in all of these courses for class 6, 7, 8, 9, 10, 11 and 12, and then we will get to calculus, which is probably, I don't know, maybe 5 classes in and of itself, and each of these classes is essentially at least 15 chapters. Each chapter is going to make up a course. But of course, the whole thing is going to be easy and fun, provided that you follow essentially my advice, because I have essentially done all of these things myself. Now I know essentially how everything works. So I'm just simply informing you. And so of course, if you listen to me, you're going to have a much easier life, and you're going to have a lot more fun, essentially. Okay, so now when you want to essentially, so then based on what we saw here, when you want to essentially compare these numbers, you will now you see that essentially, for example, for 481 and a 522, of course intuitively you would say that the 522 is larger than 481, simply because of the fact that, for example, I have a 22 over here and 81 over here. Okay, of course an 81 is larger than 22, but then over here I have 400 and I have already 500 over here. So a 500 is essentially weightier than everything else there is essentially in these two numbers. So since there is already a 500 here, that means essentially this number is the largest number. So how did we do that? Essentially what we did is that for the time being we ignored essentially the ones place value, the tens place value. Again, the ones and tens place value, we ignored them, and then we took a look at the largest place value in essentially in both the numbers. The largest place value over here is the hundredths place value and the hundredths place value. So I have essentially 400s over here, I have 500s over here, right? So that means that essentially this number is already larger than this number. Whatever these numbers might be, it doesn't really matter. Because over here I have essentially 1, 2, 3, 4, 5. And over here I have, this is a group of 100. And over here I have 1, 2, 3, and 4. 4 groups of 100. So 5 groups of 100, that's a 500. 4 groups of 100 is a 400. So whatever then you have over here, or whatever you might have over here, it doesn't matter anymore. This number is already larger, of course, right? Now what I'm going to do is that I'm going to now you understand the concept, you understand the concept of memorization, you understand the concept of understanding. And so in the next video we will continue based on the textbook. Thank you. Okay, so now let's come back to comparing numbers. Now let's see, for example, which one of these numbers is the greatest number essentially among this list. For example, we have 92, 392, 4,456, and 89,742, right? So again, you can, among essentially these numbers, you would intuitively say that essentially 89,742 is greater than any of these numbers, because this number has essentially just a 92, meaning 9 tens and 2 ones. 392 has again 9 tens, 2 ones, but then it also has essentially a 300. So it is greater than 92. 4,456 is greater than these two, because you have the 456, so it's greater than 92, and then you have 456, which is greater than 392. Simply because of the fact that essentially it is further along the number line than, for example, 300, meaning that 456 on the number line is on the right hand side of 392. You can use this essentially always in your comparison. If you imagine that you have the number line over here and it starts with a 1, suppose that this is 100, this is a 200, and this is, for example, a 300, this is a 400, this is a 500, and the number that we had was 392, 456. 392, 456. 392 would be somewhere over here. That would be 392, right? And 456 would be, that's 450. So somewhere over here would be 300, would be 456. Now you see that on the number line, basically as you move from the left towards the right, the numbers are getting larger and larger, meaning that 100 is larger than 1, 200 is larger than 100, 300 is larger than 200, and so on. So as you move towards the right, the numbers are getting larger, which means that if a number is to the right hand side of any other number on the number line, that number is going to, of course, going to be larger, right? So there you don't have to even consider the place values in the number or anything like that. Or you could just simply compare essentially the largest digits in the two numbers, meaning that, or essentially the largest place value. So the largest place value over here is 100th place value. Over here is again 100th place value. Here I have 4 groups of 100. Here I have 3 groups of 100. So of course 4 groups of 100 is going to be weightier. That's a 400. That's a 300, right? Now, so essentially 456 in this number is larger than this number, but this number also has a 4000. So of course it's going to be larger than this, and of course larger than this. And then this number over here is, essentially that's a 89,742. And it's of course helpful always to understand these numbers in the form of in another form, meaning that essentially we have a 92,392, we have 4,456, and we have 89,742, right? So we came all the way up to this number we discussed, and this number we discussed. Now, when you want to think of essentially 89,742, so what is 89,700 in terms of essentially those blocks of 100 and blocks of 10 and blocks of 1 and blocks of, I don't know, 1,000 and 10,000 and so on and so forth, right? So I have essentially 2 blocks of 1, right? So I have essentially a 2 in this number. I have another 4 which is in the 10th place value, so that's essentially 4 times 10, which is equal to 40. So I have also 40 in this number. I have this digit 7 over here, which is in the 100th place value, so that's 7 times 100, that's a 700. And of course you would read the number exactly in the same way, 89,742. So there is a 40 here, there is a 700 here, and then by the same logic there is a 9,000 over here, and then also there is an 80,000 over here, right? So then you can just simply, for example, in order to compare this number, for example, with this number, which happened to be the largest number on the list before we came to this number, you see that this number comes all the way, I mean the largest part of this number is just a 4,456. So that's a 4,000 plus a 400 plus a 50 plus a 6, right? But in this number you already have essentially an 80,000, which means that essentially this number, even if you ignore this part or this part or this part or this part, this number is still going to be larger than any of these numbers, right? So when it comes to essentially to basically to comparing numbers, for the first part, essentially when you just come to the number for the first run of your comparison, you don't really have to start from the right hand side of the number, meaning the right hand side of the number is the 1's place value, then we have essentially the 10's place value, then we have the 100's place value. Don't start from the smaller ones, because the bigger parts are still going to be weightier, so you can just simply start from the weightier parts. So then essentially when I want to compare these numbers, as a result, what I'm going to do, I'm going to take a look at this number. It has only the 10th place value. This has only a 100th place value, so that means that this is larger than this one. This has a 1000th place value, so this is larger than this one and also larger than this one. But this has a 10,000 place value, right? The 10,000 place value, and of course it's going to be larger than this number, larger than this number, and larger than this number. And then that way you can easily say that basically this number is the greatest number on this list. Or for example, let's consider another example over here. Let's say that you have 1902, you have 1920, you have 9201, you have 9000, 9021, and you have 9210, and we want to know essentially, so that's 1902, that's 1920, 9201, 9021, and 9210. Okay, and you want essentially to compare these numbers to see essentially which is the largest number, right? So we can take a look at this number, and we will see that the largest place value in this number is the thousandth place value. Again here the thousandth place value, again the thousandth place value, again the thousandth place value, again the thousandth place value. So all of these numbers essentially have the thousandth place value, which means that now I cannot rule anything out. I have to actually, now I need to essentially compare the thousand place values. So of course you know that essentially if I have essentially 9 groups of thousands, and if I have 8 groups of thousands, 9 groups of thousands would be 9,000, 8 groups of thousands would be an 8,000. So 9,000 is greater than 8,000, right? So you can just simply compare the digits over here. So I have 1,000 over here, I have 1,000 over here, I have 9,000, 9,000, 9,000, and so of course these three numbers, any of these three numbers are going to be larger than this number or this number, because there is only 1,000 over here, there is only 1,000, but in each of these there is a 9,000. So I'm going to rule these out, right? Now among these numbers, essentially all have the thousandth place value, and all have a 9 in the thousandth place value. So then I will move essentially to the smaller place value in all the numbers. The smaller place value would be this place value, which is the 100th place value, the 100th place value, and the 100th place value. And then I can compare the digits. So here if I compare the digits, I have 2 groups of 100, 2 groups of 100, and 0 groups of 100. So this number is going to be smaller than any one of these two numbers. So I'm going to rule it out. Right? Then what I'm going to do is that I'm going to, since these two digits are exactly the same, 2 and 2, I'm going to move one step essentially closer to the one step towards essentially the smaller place value, which is the 10th place value here. So in the 10th place value, I have 0 groups of 10, I have 1 group of 10, right? So then of course this number is going to be the largest number on this list, right? And so that's essentially how you would basically compare numbers. Very easy. Now, so we know the answers, and discuss it with your friends how you find the number that is the greatest. So but then it's important always to use your common sense, right? Meaning that essentially in all of these exercises that I want to solve here, of course it's not possible for me to memorize any of these things, because you would simply forget. I mean, there is no way for me to know in advance what I'm going to say or what I'm going to do. But then I simply use my logic and my common sense, and then if I don't know something, I will essentially do some sort of experiment or something, and essentially do a simple case, and then make that simple case a little bit more complicated, a little bit more complex, a little bit more complex, until I get that simple case to essentially to something that is complex enough for my application, and then I know essentially what to do. That's how you would teach yourself mathematics. Whenever you want to do anything in mathematics and you don't know how to do it, you have to do experiments, and the experiment you do it essentially simply by doing a simple case. For example, if you want to know how to compare numbers, write down a couple of one-digit numbers, then see how you can compare them. then make it a little bit more complex, meaning that the one-digit numbers essentially make them two-digit numbers, and then see how you can do that. And then make them, for example, three-digit numbers and see how that goes. And then keep, for example, one of them as a two-digit number, one of them as a three-digit number, and then see how that goes. And then essentially play with the different digits a little bit, see how you can essentially go about doing that, and then make it essentially more and more complex gradually. And that way essentially you will teach yourself mathematics, because that's how mathematics has been actually developed over thousands of years. People have been doing experimenting with different things, and now we have essentially the mathematics that we have today. Okay, so then, for example, if you want to find the greatest and the smallest number in each row, for example, you have over here, so for the smallest number, you have to go essentially for the number with the least number of digits, because essentially if I go, for example, for this number 59,785, I already have a 50,000 in this number, meaning that I have a digit in the 10,000 space value, right? So the number is already large, right? But essentially the fewer number of digits that you have, of course, the smaller the number is going to be, because essentially all of those digits that are going to, all of those large place values that are going to contribute to the high value of the number are just simply missing, right? So for the smallest number, go for the number with the least number of digits. For example, on this list, the number with the least number of digits is 18, right? So that's essentially the smallest number on this list. And the greatest number on the list is, by the same logic, the number with the most number of digits. So I have 3 digits here, 4, 2, 3, and 5 digits here. So this number, you don't even have to look at the digits essentially. Just count the number of digits. The number with the largest number of digits is going to be the largest or the greatest number, basically. Okay, so now for the second row of numbers, we have 1,473, 89,423, 100, 5,310. Right? So for the largest number, you can just simply go for the number with the largest number of digits, which is essentially this number over here. 89,423 is the largest number. And for the smallest number, go for the number with the smallest number of digits. So that would be essentially the 100 and 310. So we have 3 digits here, 3 digits here. So once essentially both the numbers have the same number of digits, then you need to essentially compare the digits, but then compare essentially the largest value digits, meaning essentially in this case, for example, the 100 place value. So then in the 100 place value I have a 1 over here, in the 100 place value I have a 3 over here, which means that essentially 310 is going to be larger than 100. And since I'm looking for the smallest number on this list, then of course I'm going to go with the 100. So that's basically that. Okay. Now let's take a look at the next numbers. We have 1833, 75,284, 111, 2,333, and 450. Now again, for the smallest number on the list, go for the number with the smallest number of digits. So this number has 4 digits, 5 digits, 4 digits, so we have 3 digits and 3 digits here. And once the numbers again have the same number of digits, you can compare the largest value digits, which is a 4 over here, a 1 over here, which means that the 450 is greater than 111, right? And so since I'm looking for the smallest number under this, I'm going to mark this number as the smallest number. Okay? Now, to go for the largest number, go for the number with the largest number of digits, which is essentially 5 digits over here. So this is the largest number on this list. Okay? Now the next number that we have here, the next numbers that we have here are 2,853, 700, 691, 9,999, and 12,002 and 124. So the smallest number would be easy, the number with the smallest number of digits, so that's 124. And the number with the largest number of digits would be the largest number. So we have 4 digits, 4 digits, 4 digits. We have 5 digits here, so that's the largest number, right? So here we have essentially, we just looked at the number of digits and found the number. The greatest number has the most thousands, and the smallest is only in hundreds or in tens, basically. So make 5 more problems, so we don't have to do that right now. And now how do we compare, for example, 4,875 and 3,542? So they have the same number of digits, so you would go essentially for the largest place value in both the numbers, which is the thousands place value, the 4 over here and the 3 over here, and then compare the 2 digits. Since 4 is greater than 3, then this number is of course greater than this number, meaning that essentially 4 in the thousands place value, that means 4 times 1,000, which is 4,000. Then 3 times 1,000 would be 3,000, so of course 4,000 would be greater than 3,000, right? And so this number is greater than this number. And this is also not very difficult. These two numbers have the same number of digits. They are both in thousands, but the digit at the thousands place in 4,975 is greater than that in 3,542, meaning that essentially the digit in the thousands place value, which is 4, is greater than the digit in thousands place value, which is 3 here, right? And as a result, this number is greater than this number. And then basically, next tell which is greater, 4,875 or 4,542. Again, over here, the two numbers have the same number of digits, so we go for the largest place value, which is the thousands place value. There is a 4 here, there is a 4 here. So that means there is a 4,000 there, there is also a 4,000 there, equal. So we need to move to the smaller place value in both the numbers. When we do so, we have a 5 over here, which is essentially a 500, and we have an 8 over here, which is an 800. So of course 800 is larger than 500. So this number is greater than this number. And so here too, the numbers have the same number of digits. Further, the digits at the thousands place are the same in both. What do we do then? We move to the next digit towards the smaller value digits. That is to the digit at the hundreds place, basically. The digit at the hundreds place is greater in 4,875 than in the other number. Therefore, essentially 4,875 is greater than this number. Now we have a couple of exercises here. We will take a look at them later on. But if the digits as 100 places are also the same in the two numbers, then what do we do? So then essentially you move to the the smaller digits, essentially to the hundredths place value in both the numbers, meaning that, for example, in these two numbers, 4,875 and 4,542, we moved essentially to the thousands place value. The digits were the same, a 4 and a 4. So then we moved to the digits in the hundreds place value, and we have an 8 over here, a 5. So then we concluded that this number is larger. But then what do we do if, for example, I have an 8 over here and also an 8 over here, right? So again, you can move essentially to the smaller digit in the numbers until you essentially, and you can do so until you get to the ones place value in both numbers. If everything, of course, if all the digits are the same, of course, the two essentially the two numbers are actually equal. None of them is greater than the other one. So then, for example, over here, if you want to compare 4,875, 4,889, so the digits 4 are the same, the digits 8 are the same, the digits 7 and 8 is greater, so this number is greater. Or to compare these two numbers, 4,875, 4,879, the 4s are the same, the 8s are the same. Of course, you have to make sure that you're comparing the two digits in the same place values. Not, for example, an 8 from a hundredths place value and, for example, some digit from the tens place value. Of course, that would not be a fair comparison. And then the 7s are also the same, meaning in the tens place value. When you move to the ones place value, you have a 5 over here, you have a 9 over here. So of course this is then weightier, and so this number is greater than this number, basically, right? So in the next video, I'm going to either leave this to you, I will take a look at this, and I will either leave it to you to do it on your own, or I will go through a couple of these myself. I'll see you in the next video, and thank you. Okay, so hello and welcome back. In the previous video, we were talking about, basically, comparing numbers. And we came all the way up to this point in the text, which is page 2. And we saw essentially this box over here that says try these. And I told you when we were here, I told you that I would let you know what is to be done with this thing later on, right? And then we came all the way up to the end of this section. Now there is something really important about, there is things that you need to know about this text so that it works in the best way possible for you. And well, of course, the text that I have chosen here, it's not by accident or anything like that. I could have chosen any, and you might actually know that there are infinite number of there are many different sources that you can choose in order to essentially to learn basic mathematics. Okay, but I have chosen this text for a reason, and the reason is that essentially when we get essentially this text goes from class 1 to 5, which we have done already and I have essentially put the whole thing in 7 hours. That's more than enough for essentially for those classes 1 to 5. Essentially everything that were important and necessary and relevant to our work, essentially in mathematics in general and calculus in particular, I have put everything in those 7 hours, and we have done that. So now we are done with that part. Now the second part of this book series is class 6, 7, 8, 9, 10, 11, and 12. Okay, and these are also, of course, very important. And then once we go through essentially this whole book series all the way up to class 12, then basically you will, if you do your job right, then essentially by the end of the series, then you will have built your essentially you'll have built a really practical and valuable, really valuable data, essentially foundation of mathematics for yourself, which works essentially like magic when you do it right. Okay, now what you need to do in this text, what you're not supposed to do, all of these as we go along, of course I will let you know. But for now, what's important here is that every bit of every single exercise or example or anything, for example, there's something like this, try these and so on, things essentially like that, something that you need to solve a problem basically. These are absolutely important, and these are an essential part of this text and must be done one by one. Now some of these I will have to do myself because there is a point in there I need to discuss those points, so that I'll have to do the exercises, some of these myself. Some of them I will ask you to do them yourself, because there is no point in me wasting your time. It would be better to give the work to yourself so that you get a chance to actually to actually do a little bit of this mathematics on your own. It would be, well, interesting and exciting as well. And but what's important here is that these exercises in the text are not supposed to be skipped at all. They are not supposed to be skipped. They have to be done one by one. Now some of them we will do them essentially together, some of them will be entrusted to yourself, and then you will do them yourself. Okay. Now one thing that, of course, you need to have access to this text, and in order to do so, then what you will do is that you will open up essentially any browser on your computer. Now the only thing is that the browser is supposed to be up to date, meaning it has to be updated, otherwise the website is not going to work properly on your, I mean, there would be essentially things that you wouldn't see, so you have to update your browser. Open your browser and then essentially go to this address that we have over here. We have https //ncert.nic.in ncert.nic.in. okay, and then you will come to the National Council of Education Research and Training of India. That's written up here. And then when you come to the website, as you can see, the language of the website is in Hindi. For example, over here it's written Hamare Bare Mein, that means about us, or and so on. You have to, of course, make the language English. So then you come to this icon over here, and it says English, so you make it English. And then you come down, scroll down, and you come to the textbook, to this textbook icon over here, and then you click on it. And then over here again, the language kind of tends to revert back to Hindi, so you have to keep making it English. So you make it English, and then over here you have ebooks. So you click on ebooks, and then over here you have PDF 1 to 12. Click on that. And then here essentially you will have access to all the books of the NCERT system. Welcome to the online textbook section, and then here you can essentially choose your class. Since we are using essentially a book of class 1, then you will choose, of course, class 1. Otherwise you could go for class 2, 3, 4. So when we get to, for example, to the book for class 2, then you will choose, for example, then class 2 essentially. And then the subject you have to choose as mathematics, and then the title. These are essentially the same book in different languages, because there is many different languages in India. So there is, for every region, there is the regional language, and of course there is different books. So you have to use the English book, Joyful Mathematics English, and you click that and you basically hit go. And then you will have Joyful Mathematics Class 1, as you can see over here. Joyful Mathematics Class 1, you have 13 chapters over here, and down here you can essentially download the complete book. And once you download it, then you have to extract it on your computer, and then you will have essentially a textbook, something like this on your computer. Of course, this is a little bit old. This is 2018, 2019, but I guess I'm going to update my textbook as well. Okay, so for now it's okay, but then I'm going to, because this is a little bit old, I have downloaded this around 8 years ago, so I will have to download the latest version for myself as well. And essentially then that's your textbook. Then you have access essentially to all the text, all the exercises and everything, and then you can basically go through the exercises. Okay, so that's it essentially for now. So now you can go and download your textbook and essentially do only this essentially only this exercise over here on a piece of paper with a pencil, a piece of paper, sit somewhere and have fun with mathematics. So I will see you in the next video with the next section, how many numbers can you make. Thank you. Okay, so next we have how many numbers can you make. Now suppose that you have these 4 digits. I mean, these 4 digits have been given to you, which are basically 7, 8, 3 and 5. 7, 8, 3 and 5, and you want to make essentially using these, we want to make essentially different 4-digit numbers in such a way that no digit is repeated in them, meaning that essentially for example, when you use a 7, you're not supposed to use it twice, you're supposed to use it only once, and that's it basically. As a result, for example, 7835 is allowed, but 7735 is not allowed, because then you would have essentially forgotten all about the 8, and then you would have used essentially the 7 twice, right? So now you want to make as many 4-digit numbers as you can. Now you might actually ask yourself the question, if I had, for example, these 4 digits, and given the condition that no digit is supposed to be repeated in the numbers that we generate, then basically how many unique numbers would I be able to actually generate using these digits? Would be an interesting question, and of course it would have applications in all kinds of branches of science, and for example in, I don't know, probably for example in cryptography, essentially in computer science, wherever you go, this kind of thing is going to have applications. Now later on, what we are going to study a chapter of the same textbooks in later classes, and that's about essentially permutation and combination. Once we study and understand these two concepts of permutation and combination, then we will be able to actually answer these types of questions, and it would actually be, and they are actually very interesting and useful concepts basically. Okay, but for now, essentially you would, for example, one possible number that you could make is that, given the condition that you're not supposed to use any digit twice, then you would have essentially a 7, for example, then an 8, for example, a 3, a 5. Then you would have 7, 8, 5, 3. Then you would have, for example, 8, 7, 5, 3. Then you would have, for example, 8, 7, I don't know, 8, 7, for example, 3, 5. And you could just keep coming up with these numbers. And you would essentially have essentially a number of such numbers. You could generate these essentially unique numbers. Okay. Now the number of such numbers that you could generate is of course something interesting and useful in mathematics, which we will learn when we get to permutations and combinations. Now, but for now, what is essentially the greatest? What is the greatest number that you can generate using these digits? And in order to be able to answer this question, essentially, I'm going to ask you another question. Now the question is, given any number of digits and given any sort of conditions, how could you come up with the greatest number and a smallest number? So, for example, if I were to use essentially these digits to create essentially this 4-digit number, of course I would have essentially, well, since it's a 4-digit number, I would have 4 digits basically. So I have 1 digit here, another digit here, another digit here, another digit here. And of course, since we're using the decimal number system, I have the ones place value here, tens place value here, hundreds place value, and a thousands place value, right? And I have to put essentially these digits one by one in these slots, and then I will essentially have this basically a number. So you know that, for example, if I pick this 8 over here, and if I put it over here, and that if I put an 8 over here, that would be just 8 ones, right? Because it's the ones place value, and 8 ones would be just an 8, right? But if the same digit, and of course you know that the decimal number system is a value-based number system, meaning that essentially each place value has essentially its own value. So if you put the 8 over here, it's going to be an 8, but if you put the 8 over here, it's going to be 8 times 1,000, which is going to be 8,000, right? So so when you want to make your number as big as possible, you have to pick the largest digit that you have at your disposal and put it in the largest place value that you have in your disposal, right? I repeat this. When you want to essentially make the largest number possible, you will of course then logically you will pick the largest digit that you have, meaning that, for example, here we have 3, 5, 7, and 8. And the largest digit among these digits is essentially the 8. Now this 8, if I put it essentially in the ones place value, it's going to be just a 1. If I put it in the thousands place value, the value of that digit in the number becomes an 8,000. So of course, if I put it over here, it's going to be contribute much more to the overall value of the number, right? So then I pick the largest place value and put it in the largest place value available in the number. So I put the 8 over here, and I already have contributed an 8,000 to the value of this number. Then again, you will pick the largest. Now, since I have used the 8 once, I'm not supposed to use it anymore. And but then I will go for the next largest digit, which is 7. And I put it in the next largest place value in the number. That's a 7 times 100, that's a 700. Whereas if I put it, for example, over here, that would be just a 7, right? Then I will pick 5, put it over here, and then I will pick 3 and put it over here. So the greatest number that I can I can create essentially is 8,753, right? Now let's see what is the smallest number that we can create here. And now I have essentially 4 digits again, and this is the ones place value, tens, hundreds, and thousands. So since I want to make the smallest number possible, I have to make sure that basically that I will contribute as little as possible to the overall value of the number by putting these digits essentially in these slots, right? Meaning that, for example, if I have this 8 over here, if I put it over here, that would be just in the ones place value. So that would be essentially 8 times a 1, which is just an 8, right? But the same 8 again, if I put it over here, since it's the thousands place value, it's going to be 8 times 1,000, which is essentially 8,000. And since I want to make the smallest number, and since I want to contribute as little as possible to the overall value of the number, I will put my 8 essentially over here in the ones place value, rather than putting it in the thousands place value, of course. Okay? And so essentially what that means is that essentially when you want to make the smallest number possible, you will get the largest digit that you have at your disposal, and then you will put it in the smallest place value in the number available to you. Okay? And you can see that essentially all of these things that I'm explaining to you here, of course, there is no way possible for me to memorize any of these things, right? All of these things that all of these things that I'm explaining here, these are based on simple logic and based on the essentially knowledge of the number itself. I know that, and of course you know the same, that this is the ones place value. We had essentially the pebble model. So we had essentially these, for example, a thousands block, we had a hundreds block, we had a tens block, and we had a ones block, right? And I know that essentially this place value, the ones place value, is just a number of these loose pebbles. These 10 blocks, they come essentially in the tens place value. These hundreds blocks come over here, and these thousands come over here. Now once you know this, then you can do anything with these numbers, and you don't have to memorize anything. Otherwise, if you memorize it, you're going to essentially forget the whole thing after a while. Okay? And of course, again, this kind of if you actually do memorize it, then it's not going to work for you in calculus anyway. So essentially there is simply no need to do that. So then again, when I want to make the smallest number, all I need to do is that pick the largest, essentially the largest digit that I have at my disposal, but then I have to essentially put it in the smallest place value in the number, so as to essentially to contribute as little as possible to the overall value of the number. So then I will put my essentially my 8 over here. Next, the next largest number is 7. I will put it in the smallest place value. The smallest is 10, 100, 1,000, so I put it in 10. Next we have the 5. I put it 5 over here, and then we have the 3. So then the smallest number that you can write is 3,578, right? And that's basically how you would solve essentially this kind of problem. Now, it says which is the greatest number you can get, or which is the smallest number, and this is the greatest and smallest number. And we already know essentially how these were basically formed. In the next video, we will talk a little bit about this, try these exercises, and thank you. Okay, so now welcome back. So now let's go through these exercises. There is good things in there, and we will have to essentially go through these, essentially all of these, try these, and also there is essentially some end of section exercises in this text. We will essentially go through each and every one of these because they are actually part of the text. If you leave them out, then the text is going to be kind of the text is not going to be complete. Okay. Now use the given digits without repetition and make the greatest and smallest 4-digit numbers. Exactly what we did in the previous video. So the digits that I have are, for example, 2874 is essentially 2, 8, 7, and 4. These are the digits. This is part A of this exercise. Now if I want to make essentially the smallest number, I have 4 digits here, so I'm going to end up with a 4-digit number, right? So 1, 2, 3, and 4 digits. And for the smallest number, as we explained in the previous video, you will go for the smallest digit that you have at your disposal, and then you will put it in the smallest place value in the number, meaning that I pick my 2 and I will put it, the smallest place value available is the 1's place value. Then as I move essentially number towards the left, the place value is going to be, essentially the value of the place value is going to be increased by a factor of 10 every time I move towards the left, basically. Meaning that essentially I have my number over here, so this is the 1's place value, this over here is the 10's place value, this over here is the 100's place value, and this over here is the 1000's place value, right? And you can see that essentially 1, 10, 100, and 1000, and you see that essentially 1 times a 10 is essentially a 10. Now 10 times a 10 is essentially 100, and 100 times a 10 is going to be essentially 1000. And there is of course a simple reason why this happens, meaning that essentially every place value, when you move essentially towards the left, if you pick, for example, this place value multiplied by 10, you'll get the value of the next place value. Again, you pick this place value, you multiply it by 10, you'll get the value of the next place value, and so on and so forth. The reason why this happens is because essentially is because of the fact that when we group our pebbles together, we always make groups of 10, right? Meaning that, for example, I have, let's say that I have essentially a 5,237 loose pebbles, for example, in a bag, right? So this is a bag, and there is 5,237 pebbles like this essentially in the bag. And I want to know what number essentially that those number of pebbles represent. So then what I'm going to do is that, of course, I'll have to count them, right? I will count them, but essentially, because I want to make my life easier, I'm going to essentially if you keep counting 1, 2, 3, 10, 100, 101, 102, 103, somewhere along the line you're going to make a mistake, right? So in order to avoid making mistakes, you start counting when you get to a 10, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's more than enough essentially. When you get a 10, you make basically a group of those, you make essentially a group out of those 10 pebbles basically, meaning that you have essentially 1, 2, 3, 4, 5, 6, and 7 and 8 and 9 and 10. And out of those 10 pebbles, I will make a group. So now this is a group of 10. And then I will start counting again from the number 1 again. So there is no way that I can make mistakes this way. So then I have 1, 2, 3, 4, and 5. I will make another group of 10, and I keep going essentially with my counting until I'm done essentially with all the 5,237 pebbles basically. Okay. Now I will get essentially a number of these basically these groups, and some loose ones basically in the end. But now you can imagine that I have, let's say I have, for example, a 523 of these groups at the end of the counting, right? So the 523 groups of 10 that I get, I put essentially 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are groups of 10. I will put them together. So this is essentially 10 groups of 10, which is equal to 100, right? And so then, of course, I will have essentially a number of these groups of 100. So now I have groups of 10. I have a group of 100, and of course these groups of 100, I will have essentially a 52 of these groups of 100. So then I can essentially come over here, and essentially this is one group of 100, another group of 100, another group of 100, and like that. That's essentially 10 times. 10 of these I will put together. That's 10 groups of 100, which is essentially a group of 1,000, right? Which is essentially then, for example, in this number you will get 5 of these groups of thousands, right? So you see the way that I'm grouping my pebbles together. Essentially, in the very process, I will come up with these different place values, the value of which is always 10 times the previous one, 10 times the previous one. Meaning that, for example, over here we have the ones place, essentially the one group basically, and then the next, essentially the next largest basically groups would be essentially 10 of these, which means that then the value of this group would be 10 times essentially these pebbles. And then essentially when you put these together, you will have essentially a group of 100, and the value of this group would be 100, which is 10 times essentially a 10. And then when you put these together, 10 of these, you will have essentially a group of 1,000, whose value is essentially 10 times the value of these groups, meaning 10 times 100 is equal to 1,000. And for the same reason, basically, when you have your number, you will have essentially to know that the place values, you can basically start with the ones place value, then multiply this by 10, as you, of course, you're moving towards the left. 1 times 10 is the 10 place value. 10 times 10 is basically the hundreds place value. 100 times 10 is basically the thousands place value, and so on and so forth. Right? So that's basically that. Okay. Now, when I want to make my, and essentially that's how I use basically these exercises in this text. You see over here, if I didn't have access to this exercise, essentially all of these different things about the place value, how we group things together and so on, and I wouldn't be able to actually discuss any of these, which are of course really important in understanding mathematics. Okay, so I have these digits, and of course, as we mentioned before, no repetition is allowed. I want to make the smallest number. So I take the smallest digit that I have at my disposal and put it in the smallest place value, which is the ones place value. So I put my 2 over here, then the smallest one would be 4. I put the 4 again in the smallest place value possible. Then the smallest would be 7. I put in the hundredths place value. Then I have excuse me, I made a mistake here. So what I want to do is that I want to make the smallest number possible, right? So which means that then I will of course have to get essentially the largest digit that I have at my disposal and put it in the smallest place value possible, right? Otherwise I would be making essentially the largest number. So with the largest digit is 8, I put it in the ones place value. Then the next largest is 7, so I put it in the tens place value. The next largest is a 4, I put it in the hundredths place value. And the next largest is a 2, I put it over here. So I have 2,478. That's the smallest number that I can make. Now the greatest number that I can make here, again, I will need essentially 4 digits. And so let's see what we can make. So in order to make the greatest digit, I'm going to go for the greatest digit that I have at my disposal and put it at the greatest basically place value in the number. So 8, I put it over here. Then the greatest is 7, I put it in the hundredths place value. Then the greatest is 4, I put it in the tens place value. Then the greatest is 2, I put it in the ones place value. So basically the number that I can make is 8,742, right? So that's one thing. Now exercise B, I'll give it to you. You can do it yourself. And essentially, again, I have to emphasize this, that you're not supposed to essentially skip anything, okay? If you skip something, then in the end you're not going to have essentially you're not going to be able to use your mathematics properly, meaning that your mathematics is going to be paralyzed. So please do not do so. Whichever exercise I leave to you, please just make a mark, and then later on, essentially, for example, at the end of the video or whenever you want to do it, please work through them so that we can essentially have the best results possible. Okay, now from these exercises, part B is yours and part D is yours because we have already discussed that. I will do part C and part E, and only because essentially there is 0 in them. So now if I were to do this, so now part C, I have the numbers, basically the digits that I have are 4750, and I want to make basically the smallest number possible using these digits. So I get essentially 4 digits over here, and here essentially the question is asking us to make essentially the greatest and smallest 4-digit numbers. Okay, when the question specifies a 4-digit number, that means that essentially your number has to be a 4-digit number. it's not supposed to become, for example, a 3-digit number or a 5-digit. It has to be explicitly a 4-digit number. You need to take that into consideration. So then, in order to make the smallest number, I'm going to choose essentially the smallest digit that I have, essentially, which in this case is a 0, and I'm going to put it in the largest place value in the number, which means that essentially then normally I would have to put the 0 over here, right? And then write the rest of the digits 1 over here, 1 over here, and 1 over here. But if I do this, I would come up with a number like, for example, 04, for example, 57. And 0457 is nothing but 457, which is a 3-digit number. It's not a 4-digit number. So of course I cannot do that, right? So then what I'm going to do is that, again, I'm going to take the smallest digit that I have, well, of course, then in this case, except for 0, and then put it in the largest place value in the number, which would be essentially the 4. So I put the 4 over here, right? And then basically I can go for 0. Now 0, I have to again essentially put it in the largest place value in the number, which would be essentially the hundredths place value in this case, right? So 0 is covered as well. Now the smallest digit that remains is a 5, so I put it over here, and then the 7, I put it over here. So now the number that I have is 4057. Is a 4057. Now for the greatest number that you can make, you have again 4 digits, and then you will essentially take the largest digit that you have and then put it in the largest place value in the number. So the largest digit is 7. I put my 7 over here. Then the largest digit is 5. I put the 5 over here. Then the largest digit is 4. So I put it over here. And then I have to put the 0 over here. So the largest number that I can create out of these digits would be 7,540, right? And then using essentially this, you can now essentially do the part E of this question as well. So we will move on to question number 2. Now make the greatest and smallest 4-digit numbers by using any one digit twice. So part A of this question, the digits that I have are 3, 8, and 7. 3, 8, and 7. And remember that you want to make essentially 4-digit numbers, and I have only 3 digits over here, so essentially a 4th digit has to come from somewhere, and that 4th digit essentially is coming from using essentially any of these digits basically twice, meaning that if I, for example, if I use essentially 3 twice, I would have essentially a 3, an 8, and a 7. So then I already have 4 digits, and I can make essentially my 4-digit number, right? And well, let's go for the smallest number that we can create. Now for the smallest number that you want to create, so then what I can do is that, suppose that I pick my essentially the largest digit that I have here, which is 8, for example, and I want to essentially use this now let me see, this gets a little bit complicated, because I have to use essentially the digit 1, the digit 8 basically, I have to use it once, right? And then there is one more digit among these digits that I'm going to use twice in order to make the smallest number possible, right? So since the digit 8 has to be used anyway, I'll have to essentially I have to put it somewhere. Now if I put it over here, that would be just essentially 8 times 1, which is essentially an 8. If I put it over here, that would be essentially 8 times 1,000. That would be essentially an 8,000, right? So I will get my digit 8, and I'll put it over here, and the value that it contributes to overall value of the number would be just 8 ones, right? By the same logic, I get my 7, put it over here in the next largest place value in the number, right? And then of course essentially the only thing that remains essentially is 2 digits which have to be filled with essentially a 3, and then I will basically use the 3 twice in order to fill the other place value, and that's essentially the number that we will end up with. And of course you can see that essentially the number happens to be 3,378. If I had put 8 in the tens place value, then of course I wouldn't have created the smallest number possible, meaning that I would have essentially 3,300, for example, 87. And of course you know that essentially 3,387 is of course greater than this number, right? So you have to put the largest digit that you have in the smallest place value in the number, right? And then for the largest number that you can create, I still need essentially 4 digits. And again, basically I will start, for example, with the digit 8, and of course you know that each and every one of these digits has to be used at least once. One of them has to be used twice because I need 4 digits, right? So then I'm going to say that I'm going to put the 8. If I put the 8 over here, the contribution would be just 8 ones, or essentially an 8. If I put the 8 over here, that would be essentially 8,000. So that would be the largest contribution possible to the number, essentially, by any of these digits, basically. And because of the fact that I'm trying to make the largest number possible, and I have to essentially to repeat one of the digits once, so then I'm going to essentially put use 8 one more time over here, and then 7 I'm going to use it over here, and then 3 I'm going to use it over here. That's 8,873. If I use essentially the 3 over here and the 7 over here, that would be 8,837. Of course, 8,873 is would be greater than this number. So this is essentially the greatest number that you can create, essentially using these digits. Now I will do one more of these, and then I will essentially the rest I will leave to you to do. I will try essentially one of these sets essentially with a 0 in them. So now suppose that the digits that I have are basically 9, 0, and 5. 9, 0, and 5, and I want to make essentially the smallest and the largest numbers possible, and one of the digits has to be used twice because I want to make essentially 4-digit numbers. And if you go for essentially for the smallest number, essentially of course the digit 0, I cannot put it over here, right? Because if I put the 0 over here, I would have 0, for example, 905 or some number like that, starting from a 0 with the 0. And this number would be just a 905, which is a 3-digit number, not a 4-digit number, and we are trying to essentially to do a 4-digit number. So the 0 cannot be used essentially in the thousands place value, right? So then if I go for the 9, and if I put the 9 essentially in the thousands place value, then I would have a 9,000. But if I put the 9 in the ones place value, I would have just essentially 9 ones, or essentially a 9. So I put the 9 over here to create the smallest number possible. And essentially, when you want to create essentially the smallest number using these digits, essentially you always want to get rid of essentially the largest digit the largest digit that you want is not the digit that you want to use twice. You want to use yours essentially. You of course logically you want to use the smallest digit that you have, and you want to use that one twice, because that means that essentially you're going to end up with the smallest number possible, right? So the 0 I cannot, so essentially that smallest digit is the 0, of course, in this case. So I put the 0, of course I cannot put it over here, so I put the essentially the 0 over here, and I use it one more time. And then I put the 5 over here, and then the smallest number is the smallest 4-digit number that I can create is 5009, right? Now for the greatest number that we can create, the greatest 4-digit number that we can create essentially using these digits, again essentially the 0 cannot be used over here, because otherwise we would create essentially a 3-digit number. So then if I use the 9 over here, the contribution would be a 9,000. If I put it over here, it would be a 9. So since I'm trying to create essentially the greatest number, I put the 9 over here to essentially go for the 9,000. And then the largest digit essentially available is a 5, which I'm going to put in the largest place value available. And then basically I have a 0, and then I can essentially well, of course I can basically I have to essentially repeat one of the digits, and since I'm trying to use essentially to create the greatest number, I'm going to repeat the 9, which is essentially the largest digit that essentially that we have here. So I put the 9 again over here in the largest place value available. Then I have the 5, I put it over here, which means that essentially that's a 50, but then I put it over here, that would be just a 5. And then the 0, I can put it over here, that's 9,950. That would be essentially the smallest and the largest numbers possible using these digits, given that essentially one of the digits has to be repeated, right? So then basically using essentially having all of this in mind, now you can essentially you can do essentially part C and part D of this exercise on your own, and then in the next video we will talk about essentially the rest of these. Number 3 and number 4, we will talk about them in the next video. Thank you. Okay, so next what we will do, we will take care of these the exercise number 3, which is essentially make the greatest and the smallest 4-digit numbers using any 4 different digits with conditions and as given. So digit 7 is always as at the ones place value. So essentially the condition here is that you want to make essentially 4-digit numbers, and I mean the number has to be a 4-digit number, and the rest of the digits you can choose as you wish. There is no problem with that. But then the digit 7 is always supposed to be at the ones place value, right? So if I go for essentially a 4-digit number like this, and if essentially the digit 7 has to be over here, then the rest of these digits can essentially need to be chosen by you, right? and you want to essentially create the smallest and the greatest numbers possible, right? Now and then of course you have the smallest and also basically the greatest number, and the digit 7 is going to be over here, and this is going to be the greatest number possible. Now in order to make the smallest number, of course you can choose from essentially for any of these place values. You can choose from any digit from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All the 10 digits in our number system. And since you want to make the smallest number possible, you go for essentially at the largest place value, you will put the smallest digit that you have, right? Meaning that and here essentially we have another condition as well, that you want to make the greatest and smallest 4-digit numbers using any 4 different digits, meaning that any digit is not supposed to be repeated, any 4 different digits. So which means that essentially I go for the smallest digit that I have over here, which would be essentially, if I put a 0 over here, then the number becomes, for example, a 0, 1, 2, for example 7, some number like this, and this would be just 127, which is basically a which is essentially a 3-digit number. So I cannot put the essentially 0, I cannot put it over here. Instead of 0, I'm going to go with 1, which is the smallest number available to me. And then again over here we have we can essentially again we have to use essentially the smallest digit available to us. 1 has already been used. Now 0 can be used, of course, so I can put 0 over here. And then again the smallest digit would be a 2, so 1027 would be the smallest number possible given essentially all of those conditions, right? Now for the greatest number, you go to the greatest place value, and you choose the greatest digit that you have over here. And of course you have to be careful not to repeat anything. So I put a 9 over here. Then again the greatest digit I put at the greatest place value, and 7 I cannot choose because it's been used once. And then so the largest number would be a 6, so 9867 would be essentially the greatest number given essentially these conditions. Okay. Now over here basically again we have basically part B of this question. We have essentially digit 4 is always at the 10th place value. So let's see essentially how we can do that. So if I want to put essentially, now again I have a 4-digit number, I put 4 at the 4th place, at the 10th place value. Again 4 at the 10th place value, and this would be the smallest and this would be the greatest numbers that we want to create. For these, essentially for the remaining digits, you can pick any digit that you want, but then you want to essentially you want to make sure that you're not going to repeat any of the digits. So then what I'm going to do is that since this is going to be the smallest number, and I can choose from 1, 2, 3, 4, 5, 6, and 7, 8, and 9, right? So if I to create the smallest number, I pick the greatest place value in the number, and I fill it with the smallest digit possible. So the smallest digit possible here is essentially a 0, but then if I put the 0 over here, then I'm going to end up with a 3-digit number, which is not something that I want to have. So I will put a 1 over here, right? And then for the second largest place value, again I have to go for the smallest digit that I can choose. Now 1 I have already chosen, but I can put the 0 over here, right? And then basically I can then essentially for the ones place value I again have to choose the smallest digit possible for me. So 0 and 1, so 2 I can use over here. So 1042 would be the smallest number that you can create using these conditions. Now for the greatest number, I will go to the greatest place value in the number and fill it with the greatest digit that I have, which is a 9. Then I choose essentially an 8, since I don't want to repeat anything. Otherwise I would have chosen 9 here as well. And then basically I put the largest digit remaining is a 7, so I put the 7 over here, and then the number becomes basically the 9847, right? And then again basically you can do basically all of these questions. Let me go through them as well. So again, you have basically a 4-digit part C of this question. You have basically a 4-digit number, and 9 is always at the hundreds place. So that the 1, 10, and 100. So 9 is always here, and 9 is always here. And I can, for the rest of these digits, I can choose from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Of course 9 has already been taken, so I cannot choose, of course, choose 9, I cannot choose anymore. So let's make this the smallest number, and let's make this the greatest number. For the smallest number, I'm going to essentially I'm going to pick the largest place value in the number and fill it with the smallest digit that I can choose. Of course, it cannot be 0 because the number becomes a 3-digit number. So I put a 1 over here. Then I can choose a 0 over here. 0, I can put it over here, and the number remains a 4-digit number. And then basically 0, 1, and then I put a 2 over here. So the number becomes basically essentially at 1902 or 1902 basically. For the greatest number, basically I go to the greatest place value in the number and fill it with the largest digit that I have, which is essentially an 8. Then basically the next digit that remains is a 7, and then the next digit that remains essentially is a 6, and then the number becomes essentially 8976. And so in the exact same way, basically you can solve essentially part D of this question as well. Now let's take a look at question number 4. Take two digits, say 2 and 3. Make 4-digit numbers using both the digits equal number of times. And which is the greatest number, which is the smallest number, and how many different numbers can you make in all? Now the question is, you take essentially any 2 digits. You take 2 digits, for example, you have the digits 2 and 3, and you want to make essentially a 4-digit number using both the digits equal number of times. Since you want to use essentially 2 digits equal number of times to create a 4-digit number, you have to use essentially the digit 2, you have to use it twice, and then the digit 3 you have to use it twice as well. So if you use the 2 twice, you would end up with 2 2s. If you use the 3 twice, you will end up with 2 3s as well. And so then we have essentially 2 2s and 2 3s. And we want to create these 4-digit numbers, and the smallest 4-digit number that we can create, and then the greatest 4-digit number that we can create, right? So so now how do we do that? How can we do that? The smallest number that we can create you will go essentially to the largest place value in the number and then fill it with the smallest digits that you have. So I put a 2 over here and also another 2 over here, and then the other the 2 threes I will put them over here. So that would be 2233, right? Now if I and then if I basically for the greatest number, I will essentially pick the greatest place value in the number and fill it with the largest digits that I have. So that would be 3, and then the 2 2s I will essentially use over here, right? Now the next part of this question is how many different numbers can you make in all? Now essentially for this part of the question, this is essentially not the right place to ask this question right now, because this question needs essentially a little bit of reasoning, and that power of reasoning, we don't have it yet, and moreover, it doesn't have any sort of application right now in what we are doing. So we have to essentially leave this for now, and then once we get to essentially permutations and combinations, then we will essentially have many essentially examples like this, and we will learn essentially how to calculate essentially then in such situations how many numbers you can make, and so on and so forth. It's unnecessary trouble for now, and it would have no application either. So we can just simply forget about this for now. So that's basically that's essentially the exercises. In the next video, we will talk about essentially this part that says stand in proper order. Thank you. Okay, hello and welcome back. Now what we will do in this video is essentially this section in the text, which is stand in proper order. And so we have essentially a number of children, some children over here. One of them is essentially this one is the tallest one, this one is the taller one, this one is the shorter one, this one is then the shorter one, and this one is the shortest one. So essentially, but they are standing essentially in such a way that there is no order in the way that essentially that they are standing. Okay, so based on their height, we can say that, for example, that this one is the tallest one, and this one is the shortest one, but then they're not standing in any sort of order, basically. So then what you want to do, essentially, if you were to stand them in the right order, one of them is essentially 160 centimeters. The other one is 154 centimeters. The other is 158 centimeters. And the other is 159 centimeters, right? So if I were to stand these children in essentially in some order, then what I would do is that I would say that, okay, so you stand essentially in such a way that the tallest one is right over here on the left hand side, and then the other children, and then the other children, and then the shortest one is basically right over here on the right hand side. Or I could also say that I mean, this way, essentially based on their height, they're not essentially mixed, basically, right? Or essentially I could say that you stand essentially in such a way that the shortest one is on the left, and then the next one, and then the next one, until we essentially reach the tallest one. We can do it in this way. And so then if I were to do it essentially in this way, So we could do it in these two ways. If I were to do it in this way, then I would put the essentially the tallest child over here. I would put the tallest child over here, and then essentially and suppose that this is, for example, the ground, and then I put the shorter one right over here, and then the shorter one right over here. So you start from the tallest, and then the shorter one, and then the shortest one essentially comes over here, right? So this child over here on the left is the tallest one, and then this child over here on the right is the shortest one. So you have essentially this kind of slanted line, and they are essentially standing in this order, right? If I were to do it essentially based on the second scheme, I could say that, okay, so essentially this is the ground, and then you start from the shortest child, and then the taller one, and then the taller one, and then the tallest one. So now we have this slanting line that is essentially in this order, meaning that essentially in the first scheme, I'm using essentially I'm starting from the essentially starting from the tallest child, and I'm ending up with the shortest child, right? In the second scheme, I'm starting from the shortest child, and I'm ending the line with the tallest child, right? Or for example, if you were to basically buy, for example, to buy an almirah is essentially covered in India. You call it almirah. There were many almirahs available, and with their price tags. So the price tags are over here. So you have 2,635, 1,897, 2,854, 1,788, 3,975, and so on and so forth. And we want to essentially arrange these based on the price tag essentially in an increasing order, or you could arrange their prices in a decreasing order. And then based on that, you would be able to decide essentially which one to buy, right? So the price tags that I have here are essentially 2,635 rupees. These are all in rupees, or you could think in dollars, in euros, whatever works for you. 1,897, 2,854, 1,788, and 3,975. These are the different prices that we have. Now we can essentially arrange the prices. We can arrange these prices in essentially in an increasing order, or in an essentially in a decreasing order. In a decreasing order, for essentially depending on what you do, essentially depending on the way that you want to think about buying them, you would either order them arrange them in an increasing order or a decreasing order. So I call this, for example, number 1 and number 2, right? And so based on number 1, I would say that in an increasing order, if I were to arrange these prices, since it's supposed to be essentially increasing, I'm going to have to essentially start from the smallest price and end up with the largest price. So the smallest price over here is 1,788. So I write essentially 1,788. Then 1,897. Then 2,635. Then 2,854. And then 3,975. So you see that essentially in an increasing order, you start essentially from the smallest price, and then you will end up with the largest price essentially on the list. So essentially you start with around 1,800 and you end up with something around 4,000, right? Now if you were to write essentially these prices in a decreasing order, of course you would have to start from the largest price and then end up with the smallest price. So then in number 2, the largest price on this list would be essentially 3,975. Then the smaller one would be a 2,854. Then the next one would be 2,635. Then the next one would be 1,897. And then the next one would be 1,788. Or essentially when you write your prices in an increasing order, if you just take the same list and then write it the other way around, meaning start from the largest number and then end with the smallest number, that would be essentially in a decreasing order, right? Now you see that essentially we had essentially these numbers over here, and because we wanted to make a buying decision, we wrote them essentially in the form of a list, in the form of an ordered list, basically, meaning that now the prices are not mixed up. There is some sort of order in them. You start essentially with some number with the smallest number, and then you will end up with the largest number, or the other way around. So essentially what we have done, essentially we can tidy our numbers up, and so that way we will be able to essentially work with our numbers in more efficient ways, right? Now if you think about this, it's actually not very different from standing these children in essentially in a line. Essentially when we stood these children in a line, we told them that the first one on the left hand side is supposed to be the tallest children, and then the shorter one, and then the shorter one, and then the shortest one, which is essentially nothing but this variation, basically. Or when we told them to stand this way, meaning start from the shortest one, and then the taller, and then the taller, and then the tallest, that would be essentially this variation over here. You start from the shortest one and then go all the way to the tallest one. So then in mathematical jargon, we call this essentially this variation number 1. We call it essentially an ascending order, and then the second variation we call it essentially a descending order, meaning that in the first variation the numbers are essentially ascending, meaning that they are getting bigger and bigger. So essentially the word ascend itself, you can think of a mountain, basically. Suppose that this is the top of the mountain, this is the base of the mountain, and when you want to when you're essentially going essentially to the top of the mountain, you're going this way and you are ascending the mountain. When you get to the top of the mountain and when you're coming down, you are descending the mountain, right? And so basically then essentially the words essentially, that's the meaning of these words. In an ascending order, you have essentially, you start with the smaller number and then you will end up with the largest number on the list. In a descending order, you will start from the largest number and then you will end up with the smallest number on the list, right? So that's basically the meaning of ascending order and descending order. Now there is a couple of examples over here. Let's go through a couple of them. Okay, so now let's do essentially these exercises related to arranging these numbers. And so we have basically arranged the following numbers in ascending order. In ascending order, essentially what that means is that you want to essentially arrange the numbers in such a way that you start from in ascending order, meaning that you keep going up. So you start from the smallest number and then you will end up with the largest number basically on the list, right? So then if you have the numbers essentially 800, you have the numbers 847 and 9754 and 8320 and 571. So you want to essentially write these numbers in ascending order. In ascending order, you will basically start from the smallest number, which in this case, so we have essentially over here we have a 3-digit number, a 3-digit number, a 4-digit number, a 4-digit number, right? Of course, the two 3-digit numbers are going to be smaller than the two 4-digit numbers, right? Because the fewer the number of the digits of the number, the smaller the numbers are going to be, right? And you want to start from the smallest number basically. So a 3-digit number here, a 3-digit number here, and the ones, the tens and the hundreds place value of this number is a 5. The hundreds place value is an 8, which means that this number is essentially smaller than this number. So I write this number 571 over here, and then this number 847. And then basically we have essentially two 4-digit numbers. So the 4-digit number, basically we have essentially the thousands place value over here is an 8. The thousands place value is a 9, right? Which means that essentially this number is smaller, 8,320, than this number. So I write this number as 9,754, and what that means is that essentially now we have written essentially these four numbers in an ascending order, meaning that we have essentially started from the smallest number and then we have ended up with the largest number. Now let's say that we have essentially these numbers over here, which is the part B of this question. Let's say that we have these numbers over here, 9801 and 25751 and 36501 and 38802. And we want to write these numbers again in an ascending order. So what is the smallest number that I want to start with? So I have a 5-digit number here, a 5-digit, a 5-digit, and a 4-digit number. So I will, of course, start with the 4-digit number because it's supposed to be the smallest number on the list. The 5-digit numbers, I have essentially at the 10,000 place value, I have a 2, I have a 3, I have a 3. So of course this number is going to be smaller than this number, smaller than this number. So I write it as 25,751. And then that's a 36,000, that's a 38,000, right? So of course 36,000 is going to be smaller than 38,000. So I write 36,501 and then 38,802. And that's basically all of your numbers in an ascending order. Next, what we want to do is that we want to write essentially these numbers in a descending order, meaning starting from the largest number all the way up to the smallest number on the list. And so then what you will do is that essentially we have these numbers. Part A of this question is a 5,000 and 7,500 and 85,400 and 7,861. So that's essentially the 4 numbers that I have. And I want to write these numbers in a descending order. So in a descending order, that means that essentially you start from the largest number, which is 85,400, because essentially on this list it's the only 5-digit number. And then you have essentially all of these 4-digit, 4-digit, and 4-digit numbers. So 7,000, 7,000, 5,000. So this is supposed to be the smallest number, right? Which is of course not what I'm looking for. I'm looking for still the largest number on the list. 7,500, 7,800. So 7,800 is going to be the largest number. Then 7,500 is going to still be the largest number, and then 5,000 is going to be the smallest number. So then the numbers can be written this way. Or part B of this question, you want to write essentially 1971 and 45,321 and 88,715 and 92,547. And you want to write again these numbers in a descending order, meaning starting from the largest number. Now this is a 4-digit number, a 5-digit, 5-digit, 5-digit. Now a 92,000 and 88,045. Of course, a 92,000 is going to be the largest number among these 5-digit numbers. So I will write 92,547, right? And then basically, and of course this 4-digit number is going to be the smallest number, so I'm going to keep it for the end of the list, right? Now among these two, 45,000 and 88,000, of course 88,000 is going to be the larger number, 88,715. And then we have essentially 45,321, and then we have 1971, and that's essentially all of your numbers in basically in a descending order, basically 92,000, 88,000, 45,000, and 1,971, right? So that's essentially all that we have so far regarding standing in proper line, which is standing in proper order, which is essentially nothing but essentially arranging numbers in an ascending order or essentially in a descending order. which is of course going to be very useful in many parts of, well, wherever you go in mathematics, you're going to be needing essentially these essentially ordering your numbers in an ascending order or descending order. It's going to have a whole lot of applications in, well, I would say every part of mathematics. So these are the things that we need to know in order to do other useful things in mathematics. Okay, so I will see you in the next video in shifting digits. Thank you. Okay, so now welcome back. Now in a few videos back, I told you I showed you essentially I showed you essentially an internet address that you could go to, essentially ncrt.nic.in, and then you could go over there, and then once you get to this website, you come down over here, you come to the textbook in order to essentially download the textbook that is supposed to be used with this course. And then you go to PDF, this icon over here, and then PDF, and then over here you can pick class 6, and then subject is mathematics, and then the book is supposed to be mathematics English class 6 or something like that. That's essentially what it was some years ago when I essentially when I downloaded the book from here. Now they have renamed the book to Ganita Prakash. Ganita means essentially mathematics, and Prakash means the sky. Okay, and well, I did actually download the textbook myself, and it seems that they have essentially, well, completely changed everything, right? They have completely, essentially, all of the chapters that I'm working here with, basically they don't even exist in that textbook. The number of chapters, essentially, they have completely reduced, and they have essentially they have essentially brought in completely new chapters into the textbook. It's a completely new textbook. Okay. Now, of course, it's not bad news that they have essentially put together a completely new textbook. And what I'm going to do is that well, the textbooks that you see here, these are the textbooks that I have been working with for a long time, for many years, essentially, for 10, I suppose, for about 10 years or so, even longer than 10 years. So I'm very familiar with them, I can work with them, and of course it's still mathematics, meaning that, of course, in mathematics since the past 10 years, as far as the basic mathematics is concerned, nothing has changed, right? And this is essentially the version of these textbooks that I'm familiar with. So what I'm going to do is that essentially you don't need to download that textbook from the address that I gave to you. And moreover, I have already downloaded the new version of the textbook, which is 2627. And I suppose that, of course, the class 7 has also changed, class 8 has, which is not a problem. I'm going to download the complete series. I will go through them, and then if there is something that is related to our work of essentially basic mathematics and calculus, I'm going to bring essentially all of those relevant things. I'm going to bring them in. Otherwise, we can just, for now, essentially we can just simply ignore them. And then basically what I'm going to do is that I'm going to make this chapter of the textbook available on essentially on Udemy, where you find this course. You can download essentially a copy of this chapter along with the course, essentially wherever you find the course on Udemy, and then we will be fine. We have no problems, and we can essentially keep going. Okay.